This isn't started.
I think so. Let me check that out.
Okay, check.
Yeah, we are live now. Okay. Assalamu alaikum everyone. Today I'm here for a very special talk with very special guest, as always, our honorable Mayssa Al Yazidi ma'am. Today is the prominent day in the world for every astronomers as well as every astronomy enthusiast, because today is the International Asteroid Day. We know that very well, right? So I will give a brief lecture, whereas Mayssa ma'am will do that. So let's introduce her. Mayssa ma'am is the founder of Tunisian Association of Young Astronomers. She is a planetary geologist, graduated in business analysis and characterization of reservoirs (ABCR) at the Faculty of Sciences of Tunisia, University Tunis El Manar, with a master thesis about the geology of Mars. In 2018, she had a fellowship at the Center for Studies and Activities for Space G Colombo, mapping the Noctis Labyrinthus grabens on Mars. She received a PhD fellowship in space science, technologies, and measurement to the study of the surface geology of Mars and Mercury. Her interest focuses on the composition and the processes, DTMs, and the 3D geomodeling. Mayssa is the National Outreach Coordinator of Tunisia in the International Astronomical Union and IAU Office for Astronomy Outreach OAO. So, without further ado, I want to say something which is, don't forget to share the live so that more people can join and learn some peculiar informations about the asteroids. So I think I should start, and let's go to the Mayssa ma'am. Yeah, welcome to the show, ma'am.
Thank you, Rifat, for the nice introduction. And I would like to say Happy Asteroid Day for everyone. So today we have a special day which we are celebrating the Asteroid Day, and it's a very particular day, the 30th of June. And what we're gonna talk is today we're gonna give a general overview about where we can find asteroids. So first of all, before I start asking where we can find asteroid, the first part of it is what is asteroid itself. Asteroid, in fact, or also we call them minor planets because they are celestial bodies. They are rocky objects from the solar system, but they cannot be a planet. They are minor planets. So asteroids are small rocky objects revolving around the sun, although asteroid orbit the sun like planets, like satellites, but their size is much more smaller to be a planet. So usually we call them minor planets, or we call them asteroids. This is the right scientific term to use. So the size of this is usually vary between hundreds of miles, that's like around 1,600 kilometers, to several feet across, like around tens of meters. The composition of asteroids is usually rocky. What does that mean? Rocky is formed from silicate, nickel, iron, and rocky material or rocky element like the Earth. The age of the asteroids is in fact the same age of the solar system because asteroids are considered one of the most primitive objects that form inside the solar system. So their age basically is the same age of the solar system. Then asteroid can be, according to the size, can be reached as large as Ceres, which the diameter of it is 940 kilometers, like something around 583 miles across. In the other end, the smallest asteroid that we can find in the solar system is something between, as I say, tens of meters, like 2 meters or 5 meters, and it's not that big. So the type of asteroids, in fact, we do have three main types. We have many types, but the main types are C, S, and M. They are three main types, but we can find as well V type, D type, which they are subdivision. It's not really a main types of asteroids. So as I mentioned, this asteroid is a rocky remnants left, or the residue of the formation of the solar system about like 4.6 billion of years ago. So the orbit of asteroids is like the same, the orbit of the same shape or the same type of the orbit of the planet and satellite, which is elliptical. And according to the NASA archive, until yesterday, the current known asteroid counting as we arrived to achieve right now is 9,580. So that's the current number of asteroids detected until nowadays. So since we talked about the type, we're gonna pass through the type of asteroid. So what kind of asteroid we do have? As I mentioned, we do have three main types of asteroid, but that doesn't exclude that we do have other types like D types, V types, but the main principal one, which are the type C, S, and M. So what is the difference between them?
Ma'am, I think we are not showing your slides, right?
Ah, you didn't see my slides?
No. We're
Oh,
not seeing the slides.
share screen. So should I repeat again?
I think so.
Now you see my
Or
slide?
not.
You see my slide?
Yeah.
Okay. So here, okay. You can see my slide, right? Hello?
Yes, ma'am. Yeah, ma'am. I can see.
Okay. So first of all, we started by what is an asteroid. As I mentioned, asteroid is small rocky object from the solar system, and they are formed when the solar system is already become to form. So asteroid, we call them asteroid or planetoid or minor planets because they are small and they don't present a large size, and their dimension is not really enough to let them say they are planet. So asteroid, from the geological point of view, they are small rocky objects turning around the sun, following elliptical orbits, and their composition is rocky. That means their composition similar to the composition of Earth, like we can find silicates, nickel, iron, clays as well. Some asteroids, as I say, orbit the sun like a planet, and they are much smaller than a planet, so we cannot call them planet. We call them minor planets, or we call them planetoid, like embryos of a big object like planets. The size of asteroid vary between 100 of miles, like if we mention 100 of miles is like something 1,500 kilometers to several feet of across. Asteroids can reach also a large size, like Ceres, which is 940 kilometers, which is about 5,583 miles. In the other end of the scale, the smallest asteroid ever studied in the solar system is just 2 meters. That's the smallest asteroid that we have in the solar system, which was observed when it made a close flyby by the Earth in October 2015. So the composition of the asteroid, as I mentioned, is very similar to a rocky object, to a rocky celestial thing, like to a rocky planet, formed by clay, silicate, nickel, iron, and their composition is somehow similar to the composition of Earth. The age of asteroids is 4.6 billion years, which is the same age of the solar system. And why we consider this age? Because asteroids are considered as the main object of, or the primary preliminary object of the solar system, that the first thing formed among the first thing formed in the solar system. Then we have three principal types of asteroid, which are type C, S, and M. It's not the only types, because we have also various types of asteroid like type D, type V, but the main principal one, or the main one, is type S, C, and M. And then asteroid like planets, like satellites, orbit the sun in elliptical orbit, turn around the sun following elliptical orbit, and the current number that until nowadays detected or studied by the NASA, which is 958,000 asteroid was detected until nowadays. So talking about the composition of asteroid, we're gonna pass through the different type of asteroid, but we're gonna pass about the main type, the principal ones. So the principal type of asteroid are three. We do have type C, type S, and type M. So we're gonna pass through them, and we're gonna understand what is the difference between it. The three BARC composition classes of asteroid are, as I say, C, S, M. The C type, or we call them the chondrite, they are asteroids which are the most common, probably consist of clay and silicate rocks, and are dark in appearance. When we see them, they have a dark appearance. So they are among the most ancient objects in the solar system. Why? Because they are characterized by the presence of chondrite. Then we're gonna find the type S. Why S? Because this is stony. So the type S are made of silicate material and nickel iron. And then the last one is the type M, which is metallic, which is formed by nickel iron, like homogeneous combination between iron and nickel. The asteroid compositional difference are related to how far from the sun formed, because this point is really important. If we gonna consider like open parentheses here, why the planets which are the closest to the sun are rocky, while the gasific planets are so far away from the sun? Because the element, the chemical element, or the geological element depends absolutely with the temperature, with higher and low temperature. So some experienced higher temperature after they formed and partly melted, with iron sinking to be center and forcing basalt or volcanic lava in the surface. And this is usually frequent for the type M, nickel iron. And then we're gonna pass through the physical characteristics. What characterize the asteroid? We saw the different type, we saw general information about size, origin, and age. What about the physical characteristics? Asteroids have usually irregular shape. We cannot say, okay, that's circular, that's rectangular, or let's have a special shape. No, their shape is really irregular. And few of the largest are nearly spheric, such as Ceres. They are often cratered. Why? Because there are a lot of impacts. So this is why the surface, if we can see here, we can see, if you can follow my neural, we can see a lot of crater in the surface because they are cratered. They are bombarded by other asteroids with different size. And this is why we have small crater, middle crater, large crater. So they are bombarded or attacked by other asteroids. So usually the surface of asteroids are cratered. The surface of most asteroids are thought to be covered in dust, as this one, for example, which is covered usually by dust. As asteroids revolve around the sun in elliptical orbit, they rotate, sometimes tumbling quite erratically. And then more than 150 asteroids are also known to have small companion moon, with some having two moons, like for example, Dictyle and Edo. They are two asteroids, which is Dictyle, it's asteroid, and have a small moon. It's here. Here is Dictyle, and here is its moon, because even the asteroid have sometime moon. This very, very small, tiny point. This is the moon for another asteroid. And then Binary or double asteroid also exist. What does that mean? That does mean that there are two asteroids rotate around each other, like binary system, like binary stars. Two asteroids rotate around each other in closed system. And then we're gonna have many asteroids seemingly have to being captured by planet's gravity and become moons. For example, like the case of Mars, Phobos, and Deimos. We have 2 moons for Mars, which there are 2 moons for Mars, and probably their hypothesis mentioned that Phobos and Deimos in the oldest time they were just asteroid, and by the gravitational attraction of Mars, Phobos and Deimos became satellite for the planet. The average temperature surface of a typical asteroid is minus 73 degrees Celsius. And then the asteroid stayed mostly unchanged for a billion of years. And this is why it's important to study asteroids, because asteroids usually they present unchanged surface, unchanged internal structures. So to study asteroids, that means to study the first steps of the formation and development of our solar system. So then the most important question, where did asteroids come from? From where they come? In fact, talking about from where asteroids come, asteroids are left over from the formation of our solar system. It's like you are preparing the cake. After you prepare a cake with chocolate, you're going to have something left. An example. When the solar system is formed, there's something left, like some rocky stuff, rocky element, just left like that from the formation of the solar system. Our solar system began about 4.6 billion of years ago, when a big cloud of gas collapsed in the center, and when the center with the force, we start forming the planet and the moon and the rocky and celestial object in the solar system. So some of the condensing dust in the cloud become a planet here, because not all of them have attracted to each other to form much more and more and more big object in the solar system. Some of the condensing dust in the cloud become a planet. The object in the asteroid belt never had the chance to be incorporated into a planet, because they didn't have the chance to be a planet. They are left from the solar system formation. They didn't have enough time and enough gravitation to attract each other to form a planet. So they are left over from that time long ago when planets formed. Early on, the birth of Jupiter prevented any planetary body from forming in the gap between Mars and Jupiter, causing this small object that were here to collide with each other and fragment into the asteroid seen today. Our hypothesis in this point suggests that the asteroid belt between Mars and Jupiter is in fact unformed planet. It was supposed to be planet between Jupiter and Mars, but since the gravitational attraction of Jupiter is so big, because we should not forget that Jupiter is the biggest planet in the solar system, so it presents the biggest attraction or gravitational force. So it was supposed to be planet here, but caused by according to the higher important gravitational force of Jupiter that didn't allow this planet to form. So what they left rocky object, rocky celestial object in this space rotating between Mars and Jupiter. And this the main source of the asteroid in the solar system. Here I mentioned some very famous asteroid like Ceres. It presents 939 kilometers of diameter, Vesta, Pallade, Aegea, which is very, very famous asteroids. So to learn more about the principal asteroid source or principal asteroid belt, which is this belt, between Mars and Mercury. Here is the first source of asteroid in the solar system, which is built of rocky object of rocky things, rocky celestial bodies between Mars and Jupiter, rotating around the Sun, following elliptical orbit, and they are the source of asteroids that we see nowadays. But it's not the only source. So most of this ancient space rubble can be found around the Sun, between Mars and Jupiter, within the main asteroid belts, which is this one. Their size range from Vesta, which is the largest at about 393 miles in diameter, to Bati, that are less than 33 feet, like something around 10 meters across. The total mass of the asteroid combined is less than that of the Earth's moon. If we're gonna summarize, if we're gonna count the number of asteroids here between Mars and Mercury, they are less than the size of the moon, according to our Earth. This is our planet, this is the moon. And if we summarize, if we take all the asteroids here, their size is still less than the size of the moon. Jupiter's massive gravity and occasionally close encounter with Mars or another object change the asteroid's orbit, because Jupiter have the highest gravity. It affects everything because it's the biggest planet in the solar system. Knocking them out of the main belt, because it has the biggest gravity, and then hurling them into space in all directions across the orbit of the other planets. So Jupiter is really the main reason of that, because he has the higher gravity. And asteroid and also fragmented, slammed into Earth and the other planet as well in the past, playing a major role in altering the geological history of the planet and evolution of life in Earth. Here we should not forget, because they are one of the hypotheses, like for example, one of the hypotheses developed before about the origin of life is not the hypothesis of Darwin, but one of the hypotheses about the origin of life in Earth could be from asteroids. Asteroids come from other planets so far away from us, bring life, bring bacteria, bring microscopic things, and arrive to the Earth. And from that impact, the life is started, because someone brings the life from outer planet to our planet through asteroids. So that's also another hypothesis that suggests the possible life by asteroids. And then asteroid classification. So we saw the different type of asteroid, which is C, S, and M. Now the different type or different classification of asteroids. So as we mentioned before, the majority of we do have main asteroid belt, which is the main asteroid between Mars and Jupiter. This asteroid belt contains the majority of known asteroids. The most asteroids that we know usually are coming, 99% coming from the main asteroid belt, which is this one, between Mars and Mercury. The most are coming from here, but that does not exclude that we do have another sources for the asteroids. So the main asteroid belt, which is the one between Mars and Mercury, contains between 1.1 and 1.9 million asteroids larger than 1 kilometer of diameter and million of smaller ones. The same asteroid belt present early in the history of the solar system. Because why? Because it's conserved the oldest celestial object in the solar system. The gravity of newly formed Jupiter brought an end to the formation of planetary bodies in this region and caused the small body to collide within another, fragmenting them into the asteroid we observe today. Because Jupiter is so selfish. He don't want anyone to be concurrent to him. He wants to be the unique big planet in the solar system. So he's very higher and big. Gravity will not let the asteroid belt here to collect each other, to connect and to form slowly, much more big objects. So this is why the size is still really small. So in the figure here, this is illustration show three possible scenarios of the evolution of asteroid belt between Mars and Jupiter. In the top panel, for example, this one, in the top panel here, Jupiter-sized planets migrate through the asteroid belt, scattering material and inhibiting the formation of life in the planet. That's the first possibility. The second scenario is this one. The second scenario is show that our solar system model a Jupiter-sized planet that moves slightly inward, but is just outside the asteroid belt. Then the third possibility is that a larger planet does not migrate at all, creating a massive asteroid belt material from the asteroid belt would bombard the planet, possibly preventing life from evolving. Here is the three possibility scenario for the evolution of asteroid belt, how it's evolved. Then, so the first source, as we say, is the asteroid belt between Mars and Jupiter. The second source is called Trojans. What is the Trojans? It's an orbit with a larger planet. This source share an orbit with a larger planet like Jupiter, but does not collide with it because they gather around two special places in the orbit, which is here we call them Lagrangian 4 and Lagrangian 5. Yeah, we call them L4 and L5. L4 and L5. There, the gravitational pull from the sun and the planet are balanced. Here we do have a balanced gravitational force. So this asteroid, they will not be attracted by Jupiter because we have a balanced force. By the Trojans' tendency to otherwise fly out of the orbit. The Jupiter Trojans form the most significant population of Trojan asteroid because each asteroid comes from L4 or L5, which is Lagrangian 4 and 5. We call them Trojans asteroids. So the Jupiter Trojans form the most significant population of Trojan asteroids, and it is thought that they are the numerous as the asteroid in the asteroid belt. They are Mars and Neptune Trojans. And NASA announced in 2011 the discovery of the Earth Trojans. That was in 2011. Does that mean that their small celestial object or rocky object turn at the same orbit of the Earth? So the diagram here illustrates, which is this one, the diagram here illustrates Lucky orbital path. What is Lucky orbital path? It's the first mission to the Trojan asteroids. Why these asteroids are very important? Because they are very important to understand what? To understand the origin of the solar system. So what Lucky space mission is a space mission dedicated by NASA to go fly by this kind of asteroid that follow the same trajectory, the same orbit of Jupiter, and study them, their main target. So the diagram here illustrates Lucky orbital's path. This mission gonna be launched this year in October 2021. So what is the target of this mission? Why NASA gonna spend billion of dollars for a space mission to go and just discover a kind of rocket project, turn around the solar, turn around Jupiter and follow the same orbit? To study what exactly? So looking space mission gonna study the surface geology, gonna study the surface color and composition. It's gonna study the interior and bulk properties, and also gonna study the satellites and rings, because that's gonna help to understand how it was, the first steps to form our solar system. Then Another important thing, so what we saw the main asteroid belt between Mars and Jupiter. We saw the Trojans source for asteroids, and the last object or the last source of not asteroid, because this is another classification, which is the near Earth asteroids. We call them NER. What is the near Earth asteroids? These objects have orbits that pass close by that of the Earth. The orbit of the near Earth asteroids pass very closer to the orbit of the Earth. This is why we call them near Earth, because they have orbit closer to our orbit for the Earth. Asteroids that actually cross Earth its orbital path are known as Earth crosser. If the NER crosses the orbit of the Earth, we call them Earth crossers, because they crossed our path, our orbit, our planet, the path of our planet. As of June 2019, 2020, because I discovered this number just yesterday for some updates. So for yesterday night, as you can see here, I checked the number of the near Earth object, and we found that the last number discovered is 10,000. From 1994 until yesterday, we have 10,780 near Earth objects. So the near Earth asteroids are known, and the number is over 1 kilometer in diameter, is thought to be 861. So if you can check here the size distribution, we have known asteroid, the one that we know, have dimension more than 1,000 meter. That's mean 1 kilometer. Then we do have few we know and few that new predicted. Total wise, we do have the dimension between 400 and 1,000 meter, and then 300, 500 meter, in which some of them all the predicted total. And then we do have something also few dimension and number we cannot determine, because we cannot know everything. The universe is vast and is large and is so big, so we cannot really determine a real exact number of the near Earth asteroid, because every day the number is increasing. Then what we can learn from asteroid, why we are doing that, why we study asteroid, why we just want to learn more about them, and why we're gonna do with this. Study asteroid is very important because asteroid formed in different location at different distance from the sun. We do have the closer asteroid, we do have the far asteroid, we do have near Earth object, we do have the Trojans belt of asteroid, the mean principal belt of asteroid. So no two asteroids are alike, and there are few ways that differ. We cannot find two asteroids similar to each other. We cannot have asteroids exactly the same composition, the same thing. It's really rare because different asteroid is different. I'm not talking here about asteroid fragmented in many pieces. No, two asteroids from different origin, they do not present the same characteristics and also the same properties. Asteroids aren't all round like the planet. They present a regular shape. They could be spheric, they could be round, they could be irregular. They have a very different shape. They have jagged and irregular shape. So that's very important. Some asteroids are hundreds of miles in diameter, while the other are just few feet, like 10 meter, 2 meter. Most asteroids are made of different kind of rocks, but some have clays of metal, such as nickel and iron, so their composition is very different. Several NASA space missions have also flown by and observed asteroids. The near Shoemaker, which is very famous space mission, landed in Eros asteroid, which is asteroid near Earth in 21st. In 21st, the near Shoemaker landed in this asteroid. Then Dawn space mission traveled to the asteroid belt in 2011. to orbit and study the second largest object there, which is Vesta. So then from Vesta is also a large like a planet, but it's not a planet. In 2011, Dawn left Vesta and went into orbit around the largest object in the asteroid belt, which is the dwarf planet Ceres. So, some important things, which is in 2016, NASA launched the Osiris-Rex, which is a spacecraft to study an asteroid near Earth named Bennu, and bring a sample of the asteroid back to the Earth. In 2018, Osiris-Rex went into orbit around Bennu. Bennu is the smallest world ever to be contributed by spacecraft because the asteroid is very small. Osiris-Rex will spend 2 years studying Bennu's surface, looking for the best place to take the samples and bring it back to the Earth. This is just illustration, it's not a real image. Why that's important? Because study the surface, study the geology, study the composition will give us a large view or gonna open our eyes about how the solar system form, how it could be the composition of our planet, how our planet gonna be evaluate and grow, how gonna be end, how our planet arrived at that level, let's say. So then, why we study them, as I say, is to learn what type of material exists billions of years ago in order to understand the formation and evolution of the planets. And also, which is very important, space right now is economy, is money, because space is elements, is iron, is phosphor, is what we cannot find it here in the Earth, we can find it in other planets. So it's not really impossible. Some of the material trapped inside might be building blocks of life. As we can say, the origin of life on Earth could be made by an asteroid that bombarded our planet and bring life with it. It's not confirmed, it's hypothesis, but it's something just suggested. But asteroid is dangerous. How asteroids could be Earth impact? That could be dangerous. Yes, the answer, yeah, asteroid is very dangerous, but when their size is very large, when the size of asteroid is large, then it's gonna be very dangerous. And at this point, in Russia, in 2013, and exactly in 15 February, an asteroid slammed into the atmosphere over the Russian city of Chelyabinsk, creating a shockwave that injured, in fact, not 1,200, 1,500 people. The spacecraft is thought to have measured about 65 feet wide when it's entered Earth's atmosphere because it was really very big. So at that point, I'm gonna show you just a few seconds of a video about that. About the Russian meteorite. Here is a TV record and TV channel about the meteorite.
Out of nowhere, a bright speck in the sky, soon streaking across the horizon, followed by an almost apocalyptic scene, a blinding flash of light, and then all hell broke loose. Dizzying explosions, shattering windows, knocking these office workers to the ground. These students were lucky. Protected by curtains from the flying glass, and these men barely escaped the blast. In the streets, pandemonium. Terrified residents thought the world was ending. People started to panic. Somebody screamed, "The end of the earth," he says. The chaos of the meteor was captured on cell phones and on dashboard cameras of cars, so popular here in Russia. The blast was so powerful, it knocked down a wall at this factory. In all, over 1,200 people were injured, mostly from broken glass. 3,000 buildings damaged, over 1 million square feet of glass shattered. Many were injured after going to the window to check out the flash in the sky. The glass shattered and bounced back on me. My beard was cut open, this man says. The meteor was believed to be about 50 feet wide, weighing a whopping 7,700 tons. That's about the same as the Eiffel Tower. It raced towards Earth at over 40,000 miles per hour. As it crashed into the atmosphere, it began to break into pieces, causing those booms and sending those powerful shock waves towards the ground, rocking a zone stretching hundreds of miles away, those shock waves causing all of the damage. As for the pieces of the meteor, one of the bigger chunks landing here, leaving that massive hole in the frozen lake. Tonight, about...
So as you can see here that asteroid, yeah, they could be dangerous, but in case they present a higher and a very big dimension, which is usually it's really rare to find a dimension like that, because usually asteroids they do not present a large dimension, but it's something possible. It could be. So then we're gonna pass through significant dates. Is very few of them is very important to recognize and to recall and remind. Significant dates linked to asteroids. The first date is 1801, which the first time when Giuseppe Piazzi discovered the first and the largest asteroid series orbiting between Mars and Jupiter. Giuseppe is Italian priest and also astronomer. 1898, Gustavus discovered Eros, one of the largest near-Earth asteroids. 1991 until 1994, the Galileo spacecraft take the first close-up image of the asteroid Gaspa and discover the first moon, later named Dactyl, orbiting in asteroid. 1997 to 100, the near spacecraft flies by Mathilde and orbit and lands in Eros. 1998, NASA established the Near-Earth Object Program Office to detect, track, and characterize potential hazardous asteroid and comet that could approach Earth. With this office is called, I mentioned here if you want, yeah, it's called the Catalina Office for Near-Earth Project Detection. And here is the website link if you are interested to check. They have their big, huge archive about the near-Earth objects detected and also studied. So it's a very important link if you are interested. Then, another significant base is 206. Ceres attain a new classification like a dwarf planet. It's not asteroid anymore, but retain its distinction as a larger known asteroid, even if it's now it's close to dwarf planet, because before it was suggested to be a large asteroid. The European Space Rosetta, in its way to study the comet in 2014, fly by and photograph asteroid stains, a rare type of asteroid composed of silicate and basalt, of volcanic rocks. Rosetta fly by asteroid Lutita, revealing a primitive survivor from the violent birth of the solar system. And the last one, which is 2011 until 2012, dwarf studied Vesta. Dawn studied Vesta. Dawn is the first spacecraft to orbit main belt asteroid and continues into the dwarf planet Ceres in 2014, as I mentioned before. So now the surprise is, let's meet Vesta. So what is Vesta? I'm gonna present for you a small video of 3 minutes, and then we're gonna talk about it. So that was Vesta. Vesta, what is it in fact? Is asteroid, very important asteroid, located approximately 1 million miles from the Earth in the solar system's main asteroid belt between Mars and Jupiter, which is the home to countless bodies that circle the Sun between that zone between Mars and Jupiter. So Vesta has a giant crater, which is the diameter of the giant crater is located in, I'm going to show you later, an image located in the pole. The diameter of this crater is 460 kilometers in diameter. The diameter of the asteroid itself is 425 kilometers. The volume of the asteroid is 7.46 multiplied by 10 square 7 kilometer cube, and the mass of it is 2.6 multiplied by 10 square 10 20 kilogram. So why this asteroid is important? Because scientists believe that the asteroid formed prior to the planet, making it one of the oldest objects in space that within our reach. After how 4 years journey, Dawn arrived to Vesta in 2011 and spent 14 months for 5 months, mapping the surface to blow up a view, shed light, and world filled with mountains, cliffs, valleys, and craters, the one that we saw them all in the picture. They are called faults, crater, impacts, and even faults. So, Darwin and Rabbit to this asteroid take as maximum as they can from the surface topography. And to watch these surface features give us impressive view or incredible view about how that could form in a small body. It's not planet. It's not satellite. So how a small celestial object like that could form these tectonic and geological features? So I'm going to show you then. Here is the geological map for the same asteroid for Vista, because this is the first thing that geologists do. The first thing is do map and maps for free. So here is the first geological map for the asteroid, in which means Vesta is the second most massive, as I say, resident in the main asteroid belt. Why it's important to study Vesta? Because it's the the second big asteroid in the main asteroid belt between Mars and Jupiter. It's the biggest one, the second biggest one. That vast collection of body orbiting the sun between Mars and Mercury. He is the one of the biggest one, the second one by order of size. So this map was made by NASA, and in which we can see here the different geological units. For example, yellow, green, gray, blue is different geological unit, different geological terrains, smooth, not smooth, all young terrain, and also the crater that we can see. Also some thrust faults, this line, the black line are thrust faults, simple faults, 60 faults. So how small body like that could have important geological features? It's very important to understand the mechanism, how it's going on, the procedure to have a planet with tectonic and also geological features important at this level. So here also I'm going to present some images of hydrogen hotspots in Vista photo, because to understand or to see the surface here, we can understand the color variation, and the color variations in the composition and also the age. Here's also the Valia Hossain and Rubria and Ochia crater apparent brightness and topography image. For example, if we're gonna compare here is the base map and here's the topographic map. So looking to the topography map, we can understand what is the highest part, what is the lowest part, what is the surface also, the situation of the first surface, elevation of the surface, and also looking to the spectrum like hydrogen hotspots map, let us understand the composition of the surface. And then here's in Vista, as we mentioned before, Vista is big. The diameter of Vista is 525 kilometers. The most particular part in Vista is that in the 524 kilometer of diameter, they are the biggest crater, which is this one. The crater is here 400, if I remember very well, it's like 480 kilometers, which is almost taking the most of the diameter of the asteroid. It's the biggest impact crater in very small asteroid like Vesta, compared to the Earth size and also compared to the giant planet. Because 524 diameter of kilometer of diameter is big, but if we compare it to the Earth's size, is nothing. So this small asteroid have a very large crater, which is also very important to study how a small asteroid like that have a very big impact and is not destroyed. It's still a complete asteroid. That's also very important to know. And by this place, I'm gonna end my presentation. And I would like to thank you, and I will welcome now any question. Thank you.
Okay, so now we will take few questions. If you have any questions, then please do comment below. Okay, we have some questions. Okay, what's Lagrangian point and how asteroid fall on that point to be Trojans?
Lagrangian point, in fact, I'm gonna show it in my slide here. So Lagrangian point is 2 points exists in the orbit of Jupiter, in which they are celestial objects. They are rest of rocky object from the formation of the solar system, rotating following the same orbit like Jupiter. And these 2 points, in fact, the attraction or the gravitational force between the Sun and Jupiter are equal. So this object that exists here, they're not gonna be attracted by the higher gravity force by Jupiter. So they are maintaining here in equilibrium force. They are safe. They are not gonna be attracted by the higher gravity force of Jupiter. So they are safe in the L4 and L5 position because they are in a point of safety where they are equilibrium between the gravitational force. So this point, L4 and L5, they are one of the main sources for the asteroid. The particularity of these sources is that they are orbiting the same trajectory or the same path like Jupiter. They are not between Mars and Jupiter now, the same path like Jupiter, and we call them Trojans asteroid because they come particularly from this position, from this location. They have different composition, not similar to the composition of the asteroid that came from the main asteroid belt between Mars and Jupiter. And they are safe. They are not really under force or under gravitational attraction by Jupiter because, as I said, they are in position and location where they are equilibrium between the two gravitational forces, so they are safe. They couldn't be attracted by the higher gravitational force of Jupiter. So we call them Lagrangian point L4 and 5 because according to Lagrangian, absolutely, and they are here like forming half arc. And as I say, they are the second source for asteroids in the solar system. I hope I answered the question.
Okay. The next one from Muhammad Tahmid. He's one of my friends. What's the difference between meteors and asteroids?
Yeah, this question is very important because there are a lot of confusion and people, I have a paper here, I have an image, I'm gonna show it. People, they have this confusion between meteorite, asteroid, and asteroid, another kind also. So we can explain because it's very important to distinguish between the different category. Because the nomination, the name asteroid, meteor, meteorite, it depends in fact from the position of the object, where it is, outside of the Earth atmosphere, inside the Earth atmosphere, closer to the Earth, outside of the Earth. So the nomination, the name asteroid, meteor, meteorite, it depends from where it exists, inside the Earth, outside the Earth, arriving to the surface of the Earth. So we can explain it. First of all, the comet is not asteroid. The comet is something totally different. It's not asteroid, and it's something coming from the belt of Kuiper, because they present a different composition. They present a different structures. Most of them are gasific, not rock. They have the core of the comet are rocky, but they are not like asteroids. So they present different shape, different composition, different source. So today the comet is outside of our topic. What is the asteroid? Asteroid, as we say, there are three main sources of asteroid. We have the near Earth objects, which is object orbiting around the orbit of the Earth. This could be source of asteroid. We have the main source of asteroid, which is the main sequence or belt between Mars and Jupiter. The third source is the Trojans object, which is Lagrangian 4 and 5, the two half arc that orbiting are the two source of asteroid that orbiting following the same path of Jupiter, and they are also the source of asteroid in the Earth. Something exists outside of the Earth, outside of our space, outside of our atmosphere, or the atmosphere of Earth is called asteroid. What is meteorite? Meteorite is something different because is still asteroid because the three of them here, starting from asteroid, we're gonna cut the comet. We're gonna cut it because the comet is something really another. Starting from asteroid, meteoroid, meteor, fireball, meteorite, all of them is the same object, the same source, is the same object, but the nomination, the name differ from where it is. Outside this Earth's atmosphere is called asteroid. Then the meteorite is a rock, fragmented, it was big. It's the same as asteroid, it was big, but it was fragmented in less small size because with the temperature, with the velocity, so it's gonna decrease the size and refer to the object before it entered to the atmosphere. So for something far away from the Earth, we call it asteroid. Before just entering, as the picture shows here, before just entering the atmosphere, we call it meteoroid, which is not asteroid. It's something gonna enter the atmosphere of the Earth, so it's gonna be meteoroid. What is meteor? Meteor effect is the same object, but it goes through. So a meteor can arrive in the Earth. In the Earth as long object shooting star in cluster meteor shower. So the meteor is something we can see like the cluster shower, and it's something already arrived to the Earth's atmosphere. It's something already passed through the Earth's atmosphere. So it's something already entered to our atmosphere. The fireball is something happen, like for example the fire show. Sometimes they say, okay, in the summer look to the fireball show or meteor shows. In fact, it's very small meteors that we can them like a very bright line. And the meteorite is a rock when just it arrived, as we can see here, the crash, the crash, this means it's meteorite, it's not meteor anymore. So the object is the same. We do have the same rock. The rock is called A. When it's outside, for example, if we have rock A, when it's outside the atmosphere, is far away from our planet, is asteroid because it's remain is in her possession, in her location. It's still there in the asteroid belt, so we call it asteroid. If it's get closer to the Earth's atmosphere, we call meteor. It didn't enter yet the Earth atmosphere, it's still outside, but it's getting closer, so we're gonna call it meteor. Then, when it's just entered the Earth's atmosphere, we're gonna call it meteor, and when it's arrived to the Earth, it's touched the soil, it's touched our soil, our street. When we found it, we pick it up from the street, from the desert. We cannot say we are picking up a meteors. No, it's not meteors. This is a meteorite because it's already arrived to the soil of the Earth. It's already arrived to the desert, touched the surface of our planet. So to summarize, the object is the same. The name or the pronunciation, not the pronunciation, but the name or the nomination, it differs from where it is. If it's still in the source, it's asteroid because it's still in the asteroid belt. Getting closer, meteorite, entered the Earth's atmosphere, meteor, and when it's arrived to the soil, to our Earth, to our desert, where we can find it, because usually meteorite, we found them in the North or South Pole or in the desert, where they are really clear places where we can find meteorite and see them, detect them easily. So at that time, when we pick up, for example, meteorite from or extraterrestrial object or rock from outside of planets, we cannot say, okay, we are going to pick up meteor. No, it's a meteorite because it's already arrived, achieved the Earth's surface. So I hope it's...
Okay, the next question is from Faisal Irfan. Why the majority of the asteroids lie between Mars and Jupiter?
Yeah, as I mentioned before, the hypothesis say that, yeah, for example, why the day is 24 hours? Why, for example, the week is 7 days? Why the asteroid between Mars and Jupiter? Why the main source of asteroid is just between Mars and Jupiter? In fact, as I mentioned, there are many hypotheses say that it was a planet. Probably it was a planet between Mars and Jupiter, but the reason for this planet didn't form is that the higher the important gravity force of Jupiter let this planet go away, didn't let this planet form. So if we're gonna see here, when the solar system formed here, there are some like rest of the planet formation just was in between, turning around. So this small object gets collected by gravitational force, by attraction force. A small body attracts another body, attracts another body, attracts another body, and with this procedure, attract, we get from small object to big object. So this object was formed between Mars and Jupiter, but the problem here, the main issue is the higher attraction of Jupiter. Here's example. For example, if we have a child with 3 years old and he is playing with his dad is 30 or 40 years old. So if we can attract each other, the father will win because the father is more big, more strong, and he's gonna win his child because his child is 3 years old. So the big gravity of Jupiter would not let this planet form. So this object was everywhere. For example, why Mars is in this location? Why the Earth is between Mars and Venus? Why this asteroid between Mars and Jupiter? This asteroid, by coincidence, they are rocks closer or rest from the formation of Jupiter, of the telluric planet, of Mars, of Mercury. The rest of the rocks just exist here by coincidence, so they get closer to each other, they attract each other by gravitational force, and slowly the procedure or the agglomeration, the attraction by force, forms slowly more big and big objects. But this big object, they are not able to form a planet because Jupiter, they will not let them, because Jupiter is so selfish, have a higher gravitational force, so he will not let this small object to agglomerate together and to form a planet. For example, this kind of question, I'm gonna say why the Earth is the third planet, counting from the Sun. Why, for example, Saturn have a very beautiful rings. So this is kind of question we need more science to answer, because, for example, why Saturn have rings while the Earth doesn't? Why, for example, the Earth have only one moon? So we need more science, because before answering this question, we need to know the origin of our system, how they come from, how this asteroid, they just formed in this location, in this position, and just in that exact time and scale. The main source here, because, for example, why most asteroids come from this asteroid belt? Because this asteroid belt contains billions of objects, lot of objects, because this is the main asteroid belt. And if we're gonna compare L4 and L5, look, for example, the number of asteroids that exist here in L4 and 5, and compared to the number of asteroids in the main principal belt is uncompared, because the number of asteroids in the main asteroid belt is billion of objects, billion of celestial objects turning between Mars and Jupiter. If we collect all of them together, and if we just for a second, for a while, stop the gravitational force of Jupiter, we're gonna find something smaller than the moon, smaller than our moon, because it's right, there are billion of objects, but the size of all of them is less than the size of the moon. So the asteroid belt exists. We don't know why it exists in that time, in that scale, in that shape. Between Mars and Mercury, it exists as the other planet exists in that order: Mars, Mercury, Mercury, Venus, Mars, Earth, and then Jupiter, Saturn, Uranus, Neptune. Why they exist just in that order? Just we don't know, because we need to understand how the first step, how the solar system started to form. What is the first magic magic steps to put the planet in their right position, in the right time and scale, and in the right shape, and also at the same equatorial plane, because we should not also forget that the planets, all of them, they exist at the same equatorial plane. And that's also support that the planet was formed by the same procedure, because to found the planet at the same equatorial plane is also ask or generate many questions, because probably it's the same procedure that led them all at the same equatorial plane. So yeah, the question we're gonna say we don't know why this asteroid belt exists exactly between Mars and Jupiter, but I'm gonna say that probably their hypothesis is not confirmed that it was supposed to be planet, but it didn't form because Jupiter he have really higher gravity, and he didn't let this planet form according to his higher gravitational force. This is why.
Okay, the next one from Kanshomik. His question is, what dimension is needed for asteroids to be minor planets?
Minor planets, for example, like Ceres, it was considered to be asteroid in the beginning, but then they changed it to put it like a dwarf planet, because they say it couldn't be really an asteroid. So below are they mentioned to say, okay, this is a dwarf planet, or this is a non-planet, or this is asteroid. The law, in fact, is made by the International Astronomical Union, because they are the only people, or the only person, and also scientists, absolutely, because the IAU, or the International Astronomical Union, is the only union in the world that nominate the name or select the name of and then the dimension of asteroid, to say, okay, this is asteroid, or this is nanoplanet, is by scientists. For example, for the International Astronomical Union, how we nominated the name of object, for example, like Pluto. Why the whole world decided to take it out of the planet as a class? It's not a planet. The solar system have 8 planets, 4 rocky planets, 4 gasific planets. Why before Pluto he was considered like a planet? Because it was voted by the International Astronomical Union and also scientists and researchers, because it's by vote. So when scientists, when astronomers agree that this is the limit, this is the minimum dimension to say, okay, this couldn't be asteroid, this is a planet, then they class it like a planet by vote. So all the people meet and they vote, okay, this is very small, cannot be a planet. This is the dimension is particular, so we're gonna put it like planet or asteroid. This dimension is ready according to that level to say, okay, that's something really important. So to the size of the asteroid, I think it should be something around 1,000 kilometers, because Vesta, which is the second biggest asteroid in the main asteroid belt, and it presents dimension of 5,024 kilometers, which is the second one. So it could be something around, if we consider our moon, it could be something around 1,000 kilometers. I guess from 1,000 kilometers of diameter, we cannot talk about asteroid anymore, because it's gonna be really somehow big compared to the asteroid size, and also it's gonna be somehow compared to the satellite's dimension and or dwarf even planet, if it's very, very important, the diameter. So the parameter for or the limit to say, okay, that could be this, and that could be this, that could be asteroid, planet, a satellite, is nominated by the scientists around the world, from ESA, from the European Space Agency, from the NASA, from the International Astronomical Union. They meet and they fix the limits. Say, okay, from under this limit, we cannot talk about asteroid. You're gonna talk about something much more big. For example, like Pluto. Pluto is not anymore a planet, so it's just now he's outside. So I hope I answered the question.
Okay, Owen Roman Khan has a question. Owen, unmute your mic, please.
Sorry.
Yeah.
But a big asteroid will come to hit Earth. How could we protect our birthplace?
Sorry, I didn't hear you very well.
Okay, his question is, I guess,
asteroid will come to hit Earth. How could we protect our birthplace?
ma'am, you got it?
No, I didn't hear him.
Okay, I'm telling that. If a large asteroid will come to hit the Earth, then how could we protect our birthplace?
Yeah, in fact, there are many projects going to study, and there are also drafted projects for how we can protect our Earth from asteroids. There are a lot of projects, and for example, among of them, some scientists say, okay, we should have some spacecraft which is gonna generate a wave or microwave vibration, so it could destroy the asteroid before it arrived to the Earth. That's also one of the craziest project, because to send a spacecraft with infrared or higher energy waves to just try to detect the asteroid before it arrived and destroy it by kind of energy before it arrived at the Earth is somehow, I think, dangerous. Another point that their projects say that we can isolate them or we can push them away with magnetic field, like we send mission or we send spacecraft that generates a magnetic field, so it can push away the asteroid. Also, there are another project is to destroy them. Like, for example, because we can study asteroid, you can study their trajectory, we can study exactly which time, which day, which for example, possibility can bring. For example, if it's dangerous or not, if it's something really could attack our Earth at higher level or not. So the luckiest part or the bright part is that we can study asteroid, because we can study their trajectory, we can study their periods, we can study also their parameter, and we can find that, okay, in that day, in that time, we do have asteroid passing through our surface. So there are projects, but no one of them are made right now. For example, until nowadays, we don't have any project that protect us from the asteroid. The only protection is to study the asteroid, study their orbit, study if they could attack us or not, if they can arrive to our planet or not, because through what? Through studying the orbit. Because, for example, if we know the Earth is rotating like this, if asteroid pass through our orbit and then they crash together, we can calculate it, because it's only mathematical calculation. We can calculate if two orbits can cross each other, because we already know the orbit of the Earth, and if they are asteroid, they have elliptical orbit. So if he comes like long time away, long distance away, so we can calculate if he can cross our planet or not. So we can calculate the percentage of dangerous situation, and also we can calculate when he will come back, because they are in elliptical orbit. So if the asteroid come, he will come back again. But that will not be soon. Absolutely, it's like hundreds of years, because their asteroid, they come far away from the universe, and to determine the complete tour, it takes for them millions of years to determine, because don't forget the shape of the orbit is elliptical. So to arrive from far away, complete the tour, and back again, and turn again to the Earth, it's gonna take hundreds of years. So as a state of now, the only protection that scientists do is study the orbit of asteroid, study the possibility of cross-cutting between the Earth's orbit and the asteroid's orbit, because in that case it could be dangerous in case the asteroid is really with higher size. Future project, I'm gonna say they are kind of future project to kind of protection from asteroid, like send spacecraft, destroy asteroid before coming. For example, if they know that asteroid is coming across the Earth, so they're gonna send spacecraft and pew, they bomb it in the space, like they send for it bomb and they destroy it in the space outside. Or send magnetic waves and try to push it away, like to change the orbit of the asteroid. For example, if this is the Earth and asteroid coming like that, so we can send for him some magnetic waves so he can change the direction and go back in another direction. This is just a draft of project. Another project is to, as I say, to use higher energy to destroy them, like infrared waves are kind of waves, higher waves like that, to just push them away or to destroy them before arrive to or achieve our planet. I hope it's clear.
Okay, some few questions, ma'am. Can I take, if you do permit? Okay. The question from Arun Bilathara: how does the asteroid reach in the Earth's atmosphere when they have a separate asteroid belt?
How does the asteroid reach in the atmosphere when they have separate belt? Separate asteroid belt. I didn't get clear the question about the separate asteroid belt. As I say, we do have the main belt of asteroid, which is the belt between Mars and Mercury. The second belt is the belt are the celestial object that's rotating the same orbit of Jupiter. So, for example, if you're gonna see here, how an object rotating a perfect linear path, like for example this one. If we're gonna consider that we have asteroid from here, so he is rotating perfectly and linearly the orbits without any problem. So how it comes from here to the Earth? Because he is moving perfectly, following the orbit, following the trajectory, and without any problem. So how a quiet object from here can be just moving on to the Earth? In fact, it could be by another object. For example, if we're gonna consider that there are object here named A. A is moving perfectly, and suddenly another object comes from the Earth, push it away, so this object move on and arrive to the Earth. It's like a pushman. They are object turning carefully, and then another object come and push it away. So it's gonna push it to another planet, because it's like, as I say, if we're gonna consider, okay, this is object rotating perfectly without any problem. Suddenly another object comes and push it away. So they're gonna push it away for other planet. They're gonna attack other planet, other surface, other also asteroid. For example, if we see the surface of the asteroid usually have a lot of crater in the surface, and this is coming from what they didn't made like that by themselves. Asteroid, in fact, they have attacked. For example, if you're gonna see here Vista, this is stamps, or this is the signatures of another attack by another asteroid. This is the result of another attack by another asteroid, and this is crater impact. So all this crater impact is the signatures, is the proof that these asteroids have been bombarded by many other asteroids. It was fine turning in his place, in his location, and another asteroids come hit him here in this location. So what it left was the traces, and this asteroid moved to another place, because they are, in fact, they are not fixed. Our asteroid is moving, but there are also another 1,000 of belt of asteroid that moving in another different places, and also they hit each other. So if you have something rotating fixedly like that, another asteroid come from so far away and hit him. So when it hit him, it go to another planet. And this is how the asteroid arrived to the Earth. For example, some ask the question, the asteroids are not in the asteroid belt, so how they just arrive to the Earth? They get hit by other asteroids. They crush crush each other. For example, they are rotating and sometimes they crush each other. So this is why they let asteroid move on and achieve other planets or other surfaces. So I didn't get the question, so I hope my explanation was clear and I answered what is the that.
Okay. The next question is, can Vesta hit Earth?
When it's heated by something.
One more question, ma'am. He has mentioned, I read in a report that asteroids hit Earth every 10,000 years. Is this true, ma'am?
Yeah, because recent research say that it's really rare that asteroid hit Earth. It's really rare, but it can exist. We cannot say, okay, 100% asteroids are not coming. No, we cannot guarantee really because the universe is vast. The universe is really so big, so we cannot guarantee that, okay, we know everything and no, there are no asteroids coming. We cannot, because we can find asteroids from other planets, from other galaxies, from other solar system. We don't know, because as maximum, as you know, at the state of now, it still is not enough to say, okay, we don't have risk to get hit by asteroid. No, it's not enough. Asteroid exists. As for example, in our solar system, we have 3 main sources of asteroid. Don't forget that there are billion of solar system, and each solar system have or has or will have asteroid source, asteroid belt. So as I said of now, our view for the universe is still really small. We need to know more about the universe to discover new things. And yeah, according to recent research, they say that every like 10 million of years, there are possibility that we get hit by asteroid. Like for example, what's happened in Russia in 2013, but that big asteroid. Asteroids, as I say, they are risky. They are scary, but when they are scary, when they have a big size. As a rock, it's not scary because it's like the rock in the earth, because in the end it's a rock. It's silicate, it's iron, it's metallic composite. It's not scary. It looks like I'm taking rock from the earth. It's not scary. The only scary part of asteroid when it's big, because when it's big, it's gonna make a disaster in the earth, because it's gonna attack houses. It's gonna could bring broke things, broke cars, and also it could even, for example, like Russia in 2013 attack or hit 1,500 person was in the hospital. In 2013, 1,500 from one just asteroid was just lying in the hospital for that accident. So yeah, the recent research say, yeah, according to the recent study, 10,000 year we could be hit. It's like approximative number. We could be hit by asteroid, but it's not sure because we don't know everything in the universe. We need to know more. It's approximative estimation, but it's not definitive explanation or estimation.
Okay. The next question, and this is the last question I will take. The question isn't so clear, but I guessed it. Like, is it due to the motion of asteroid that crash or collides with another planet?
Yeah, in fact, when asteroid and planet crash each other or collides with each other, is in fact, yeah, it's when the orbit of them cross each other. For example, if we're gonna consider the Earth is, we know we know, for example, the orbit of the Earth, right? And the asteroid is like that. For example, if the asteroid is coming and it was be oriented by another asteroid. For example, you have an asteroid like that, it was be hitting by another asteroid, so it cross the Earth's orbit. So the two orbit, when it's crossed, it's gonna cross between the two celestial object, whatever they are, asteroid or planet. So when two objects across each other, and especially absolutely not at the same altitude, because for example, the orbit could be crossed like that, but also could be crossed like that. So when asteroids cross our orbit, that means that they just go upper part, just go up to our orbit. If I look from the top, I'm gonna see two orbit crossing like this from the top. But in reality, it's not. It's like that. The orbit is so far away because this is what I see from the top. There are difference between the two orbits. So if I'm gonna see from the top, I'm gonna see a cross like that. I'm gonna see two orbit crossing. In that case, we're gonna say this asteroid are Earth is orbit across because they cross the Earth orbit. But when the asteroid across the Earth's orbit at the same latitude, at the same elevation, because the orbit can be crossed like this, as I say, and they can be crossed like this. When they cross it at the same altitude, at the same elevation, that means they just cross like that. That means the asteroid will attack the Earth. But if it's crossed like that from a higher elevation, from a different elevation, so at that time is not a problem because the asteroid gonna pass up to our planet, so we can see it in the surface. We can see the trajectory of asteroid, but it will not hit us because it's a orbit cross, but it's not at the same elevation. So when two objects crash or together, that means they are orbit cross and they are at the same elevation. That means that they are at the same plane, elliptical plane, at the same elliptical plane, so they coincide all together and they cross. The orbit can change when asteroid attacked by another asteroid. For example, if they are asteroid in fixed position, like for example the asteroid from the main asteroid belt between Mars and Mercury, asteroids are fixing and moving slowly and perfectly without any problem. But if they are another asteroid from so far away come and hit one of the asteroids from the main asteroid belt, the trajectory gonna change because if you're gonna move like that and he got hit by other asteroids, so I'm gonna change the trajectory to another direction, and this also causes a collision because the trajectory of the trajectory of asteroid is usually determinate. We can determine. We're gonna say, okay, at that time, that position, that asteroid gonna pass from that country at that coordinates. When it's gonna change, that means that trajectory gonna heated, or that asteroid gonna be heated by another object that it change its trajectory. It could be also a gravitational force for a very big planet like Jupiter that could also change the trajectory, and also the sun, because the sun is the biggest object or biggest celestial object in the solar system, so it's always attract things to her because it's the highest and also the biggest object in the solar system. So yeah, the collision is possible when we have orbit cross, and when we are talking about orbit cross at the same elliptical plane. That's mean the same elevation. It's not like that. It's not like that. It's just at the same elevation.
Okay, ma'am, the pre-requested question is here. Mir Sakwat Hossain, is it possible to calculate asteroid's diameter from its magnitude? This is the last question. I'll take any question.
Magnitude, we can determine from the magnitude, because they are equation. Their equation usually we use it to determine the apparent diameter of the sun. So it should be possible. Yeah, we can probably determine the diameter of the asteroid from its magnitude, because I remember, as I say, their equation we use it usually to determine the apparent size of the Mars, like the apparent diameter of the sun, and we use for that the magnitude. So it should be practical. Why not? We cannot use it for the asteroid. So I think now in using the magnitude of the asteroid, we can absolutely, I think, determine the diameter, because the magnitude also affect the diameter. we do have the apparent magnitude and also their equation. I'm pretty sure about that. Using the magnitude, we can carry out the diameter.
Okay. Uh, Thank you so much, ma'am, for your precious time, and we are glad to get back to you again. I hope everyone has joined the live talk and enjoyed a lot and have learned a lot of information from you. So thank you so much, ma'am, again.
Thank you so
Thank you
much.
so much. Thank you for the invitation and for the nice day here with you for Asteroid Day, and I wish for you a happy Asteroid Day.
Okay. So if you want to join our community, then go to the BARC website, www.barcbd.org. Choose your sectors and fill out the form. Simple. It's so simple. Until then, stay tuned with BARC because more amazing events are forthcoming and live talks are also coming. So thank you for joining, everyone. Stay tuned with BARC. Thank you. Thank you,
Thank you.
ma'am.
Bye.
See you guys. Asteroid.